Hello, physics students. So this is going to be more accelerated motion. And so we are given here a table, position time data. So here's our table with the position time data for a cart rolling up an inclined track after being given a big push. Plot a position versus time graph and sketch a smooth curve through the points. So what we're going to do is take our points that are given and start sketching them. So we have 0, 0. And then at 1 second, the cart was at 55 centimeters. And I like to make points or just marks here because sometimes I get lost looking for the right line. All right, and so at 2 seconds is at 100 centimeters. At 3 seconds, the object was at 135 centimeters. So this is 120, 30, 135. And then at 4 seconds, the object was at 155 centimeters. And at 5 seconds, the object was at 170 centimeters. And then at 6 seconds, it is 180 centimeters. So I'm just going to take my eraser and erase all my little marks here so I don't get lost and confused. You can keep yours if you want. That's fine. Okay, this is just because I'm presenting to you. I probably wouldn't erase it. So now I'm just making my smooth curve through my graph. All right, and so next our directions tell us that we're going to sketch tangent lines at 1 second, 3 seconds, and 5 seconds. And so we're going to take a look at what that is going to look like. So at 1 second, remember a tangent line touches the point exactly at one point, except, I'm not very good at making these tangent lines. Okay, and so here is our other tangent line. And then at 5 seconds, this makes a tangent line like this. And so we see here that we have this starting point right here, and we see that this is kind of a steep slope. All right, so it's a steep slope. And over here, we see that the slope is now a little bit flat. Okay, and so if you remember on a position time graph, each of these slopes is a velocity. Okay, so that means that if it's a steep slope, then that means it's kind of fast. And a flatter slope would represent something that's kind of moving slow. And so objects that are coming from a fast velocity and getting to a slow velocity, we would say that that object is slowing down. And we see also that the position here is increasing. So as time is increasing, we see that we started off at 0 and we kept going up in position. So you would say that this object is slowing down in the positive direction. Okay. And so now we're going to go ahead and sketch the velocity graph. So the velocity graph started off with something that was high in velocity, and then it went someplace low in velocity, almost to a stop. Okay, and so the total displacement for this is we would take a look at our position time graph. Okay, and so this tells us, or let me change the color here. All right, maybe that'll stay. Okay, so this tells us that is the final position, and this is our initial position. So we're going to take our displacement. Actually, let me change the color. So our delta x is equal to our final position minus initial position of 180 centimeters minus 0 centimeters, and it's going to give us 180 centimeters. So our total displacement is 180 centimeters. And we see this on the graph in the area in our velocity time graph. So in a position time graph, we just kind of look at the last number and the first number. And here we look at the area. So the area is going to be our displacement. And the area here is now a triangle. So the area of a triangle is going to be 1/2 base times height. And our height here is going to be time. And our base is going to be velocity. Okay, so then our area is going to be 1/2 base times height. And we see this on the graph in the area of a VT graph. Okay, and the total displacement is going to be 180 centimeters using the information from the position time graph. And so now here we're going to find out what this number is, okay, because we don't know what that is. We're going to use this formula, delta x is equal to 1/2 VT. So 180 centimeters is equal to 1/2 V times 6 seconds. And remember that V is the one that we don't know, right? So this is going to be our unknown, and we're trying to use algebra to find out what it is. And so we have 180 centimeters is equal to 1/2 times 6 seconds times V, which is going to be 180 centimeters is equal to 3 seconds times velocity. And we're going to divide by 3 seconds on both sides. And we have velocity is equal to 60 centimeters per second. So our answer for this is going to be 60 centimeters per second is our mystery velocity here. So let me go ahead and erase this and write in 60 centimeters per second. All right, and so now we're going to find out what the slope is. And the slope is the acceleration. So last class we talked about how there was constant velocity, and so this would make like a rectangle shape, and now we have a changing velocity or a constant acceleration. And so our constant acceleration is just going to be a is equal to final velocity minus initial velocity over final time minus initial time. And our final velocity here is 0 centimeters per second minus our initial velocity of 60 centimeters per second over 6 seconds minus 0 seconds. And we have negative 60 centimeters per second over 6, which is going to be negative 10 centimeters per second per second. All right, so our slope, which is our acceleration, is negative 10 centimeters per second, and that value tells us that for every 1 second, the cart decreases speed by 10 centimeters per second. And that is it.